Hi, I'm Jesse Anderson from the Northern Nevada Software Developers Group, and today I'd like to talk about the post-Agile checklist, what to do after you've put Agile in place. So in a previous presentation I talked about the I talked about getting that foundation started. Now let's assume that you've put Agile in place and it's going smoothly now. Now we need to talk about what kinds of things can be done to improve your Agile setup. So there's a lot of things that can be done to improve it. This is a short list, and in reality, each one of these deserves its own presentation. So this will be more of a cursory overview, more of a to get you to think, maybe Google search afterwards to look and see what you could do to improve that. So you've got source control, unit tests, automated builds, continuous delivery. And we'll talk more in depth about each one. So, source control. What is source control? It's a program. You may have heard them called Subversion. You may have heard of Git, Mercurial. There's a lot. SourceSafe. There's a lot of different ones. So, what it does for you is it allows developers to work in tandem. So if you don't have it, you need the ability to have your developers collaborating. They need to be sharing the same set of code. They need a program in place to allow them to do that. Doing this manually via patches or having a centralized file repository, those don't work as well because there's that human element involved. We want a piece of software doing that. So you might be thinking, well, this is for a team, but in my opinion, it's important even in single-person teams. And in my personal case, whenever I'm doing a project, even a personal project, I keep that in source control because I need to be able to see what I did in a previous version. I want to see how things evolved over the course of time. And this is important when you're dealing with even a project for yourself or as a single person in a team. You can keep track of what's going on. So that leads into the third thing. How did your code change? You can actually look back through revisions. Each source control program may have a different word for revision, but you can look back and see at this revision or this point in time, when you check something in, this is how it differed from this version or in this version. Or you can do things like, when was this file changed? And more importantly, using good comments. When you're checking in code, you can actually comment and say, this is what I did during this check-in. And you want to have an iterative process. And in my opinion, it should be whenever the code's compiling and you have a decent chunk of code, you'll want to check that in. You want to keep things off your machine. I want to be able to walk away from my machine and not worry that my code is going to go away. So, what if you already have it in place? Are you using source control correctly? So I talked a little bit about, you may have source control, but you may be doing things that source control or your particular source control system may not allow you to do well. You may need to look at other source control systems to allow you to do that. If you have a lot of remote teams around the world in physically disparate locations, you may think about a distributed source control system where that allows people to work basically disconnected. They're able to check in locally. You may have heard it called distributed version control systems. So that would be version control systems like Mercurial and Git. Those will allow you to be completely disconnected off the internet, yet be able to check things in. And when you get back online, you can push those changes up to a centralized server, and then everybody in the rest of the team can share that code. You also have improved merging. You want one of the big difficulties of source control and large teams is branches. If you can't merge source code from one branch to another easily, you're going to have some very difficult problems. And so those are things to think about when you're are you using source control correctly? So the next one is unit tests. So unit tests are a way to either test a new feature or test a bug. So what this does is it will exercise the source control of the program in a way that will test that feature to see if it breaks. Or if you have certain things that it needs to check for, you would actually check for those using a unit test. So what you're doing is, if you don't have it, you need to know, does that new feature that you just put in, does it really work? And if you're dealing with common code, there's always a chance that fixing one thing broke something in another place. So did you break anything else? There should be unit tests that are encompassing the entire project and all the facets of it. You need to know, did that change here break something over here? Your unit tests can tell you that. Did your bug really fix it? Did you really fix your bug? That's what that should say. It's if you what you should do, in my opinion, when you're doing a unit test, is if a bug comes in, you should write a unit test that tries to simulate what that bug is supposed to do as much as possible. So you write that, run that test. That test should fail. Then you're going to fix that bug. Then you rerun that unit test that you just wrote to test it, and it should pass. So you have two things that come out of that. That will allow you to say, I fixed this bug, and this bug is not going to happen again, because there's a test that says, that specifically checked for that, and for each person who checks in after. This is very important, so that you're not, so that you're moving forward. You're not taking one step forward, 2 steps back every time you check in. You know that when you check in, you have a very good certainty that the code won't break in that way again. So, if you already have it, is your code exercised thoroughly? That means, in general, a lot of unit tests I've seen are positive assertions. Did it go through? Did it flow in the path that I expected it to? So, you're going from point A to point B. Did you make it there? Yes, unit test passes. But what about negative? Negative tests are things like, you may have code in your program that says, if the value is negative, throw an exception. If the value is within this range, do this different. You need to have code pass. You need to move in that negative way also. You need to check that if that -1 is reached, that it actually throws that error. That unit test should do that. It shouldn't just be the positive. Did it go through this happy path of things? So, an off-topic, another slide unto itself, another presentation unto itself. Code coverage. Are all the paths through your code checked? And you can Google code coverage for more information about that. Are the code paths real world? What that means is you may have a product that is entered in through a web service, and things are done, and a thing is spit out. But if your unit tests only check for this class and don't go through the actual paths that the customers go through, there may be a bug between here and here, or something that changes between where the web service calls and actually comes into your program. So when you're creating your code paths for your unit tests, you need to try and act as much as possible as that client that goes through. So when you add new code, you're not just checking, does this very small piece work? Does the whole thing work the way it was before? There's other things that you can do. You want to get other automated testing. Unit tests are a good piece of that, but there's other things that you may need to do. If you have a user interface, you should be exercising that user interface in a automated fashion. You really want to think about that. That doesn't replace a QA person, mind you, but that would be in addition. These are things that we found in the past. We need to exercise it in those ways. Automated builds. Automated builds is an automatic way to actually create your software, to build consumable binaries of it, depending on the program language, of course. you don't have it, you want to take out manual steps. So right now, let's say, anytime somebody needs a build, they walk over to Bill and say, can you build this for me? Bill is then interrupted, has to take whatever time, and actually build that software. That's not good. The other problem, how is Bill's machine set up? Let's say we're dealing with DLLs and that sort of thing. It may not be linking correctly. You don't want to send out for public consumption things that are built on a developer's machine. You want something that is always in a stable state, that's just used for builds, and you want to build it that way so that you know that it's stable, that things are not changing. In my case, and I think every programmer does it, when I'm working on something, I'm only looking at does my part compile. But there may be a lot of other modules surrounding that change may break the compile. So when you have an automated build system, it will build everything, and it will tell you, did this build fail? Other things, maybe you missed a file when you were checking in. So maybe it didn't add a file, maybe a file wasn't checked in or updated. That automated build test will completely check out the entire branch and say, did this work? It may work on your machine, but it may not be working actually pulled out of source control. So if you already have it, are you outputting something that's a consumable output? Let's say like an installer. You want to be able to be removing as many manual steps as possible. You want something that's ready to go right then. And you want to be able to give that to a QA person. So, continuous delivery. The previous two slides were talking about unit tests and automated builds. Well, imagine putting both of those together into an automated thing that's linked together, that's doing all of this. So, when you check in something into source control, it will automatically create that build for you. And not just that, it will run your unit tests for you. So this takes out a lot of extra effort from developers. It will free them up to do other things. So some of the problems that this helps mitigate is, did you remember to run the tests? Those tests may take an hour in some cases. Some people have thousands of unit tests that run. Most developers, I know personally I wouldn't, I don't have time to run every test. I need to be able to know that something else is going to run those tests. I'll run the tests for the module that I was working on. I want to make sure those pass, but it may have broken something over there or something in this module. We need to run all those unit tests, and it's up to the continuous delivery server to figure out when it did, to figure out when something needs to be run. Can you easily tell when the build broke? So if you forgot, let's say you don't have enough time to run it each time. So you check in, let's say a month goes by, let's say a week goes by. You rerun the unit tests, and something isn't passing. When did that unit test break? Well, you're going to have a fun time with that. You're going to have to run, okay, so did the first one do it? Did that revision do it? Did this revision do it? You need to figure that out manually. But if you have continuous delivery, you look back, and in many cases it will actually say, there'll be a link there, which build actually broke this. It will tell you, this unit test passing is new. Your code, or the person who checked in for this revision, broke it. It will automatically tell you that. That will take out so much guessing and effort of when did it break, because if you're checking in often enough, you'll have a very small chunk of code, or a very small piece of code to look through for that. So, if you already have it, can you do a deploy with a single click? That really goes for developers, QA, support. If you're trying to figure out, did something happen? Can I replicate this problem that is happening in the field? If you can do a single click and it deploys things, it gets it ready to go, and you can start testing knowing that your environment is sane and that you can go from there, that is a big bonus. Oftentimes, you've got a list this big,